Hello students. So as you know, we are talking about system of particles and rotational motion. So till now we have completed some of the topics of this chapter, like center of mass we have completed, motion of that center of mass, and linear momentum of a system of particles also we have discussed. And in the last class, vector product of two vectors and angular velocity and its relation to linear velocity, and some of the concept of torque also we have discussed. Okay, means these much points we have already covered, right? So we are remaining with some more points in this chapter. Okay, maybe very soon you will be starting with your offline classes. Okay, so there also we'll study about all these topics in detail, right? So here I'm going for the next topic in this chapter, that is much more detail about torque and angular momentum. Okay, so as I told you in the last class only, whenever an object it is moving in a linear motion, so at that time, to change its state of rest also or motion also, means any object if it is at rest, if you want it to move, you have to apply the force, right? And if any object it is under motion already, if you want to stop it, if you want to make it to be at rest, there also you have to apply the force. Like when the objects are moving rotational motion, when the objects are moving in a rotational motion, at that time the force acting on the particle is come with the name torque. Okay, this torque is nothing but what? It is just one effect, one rotational effect of the body. Whenever the rotating objects are under rotational motion, that turning effect or that rotating effect of the force about any axis, means if this is one rigid body, it is rotating around this axis, you consider, means I told the example of pen only. So if I tie a paper, means otherwise, means this paper only you consider, if I make a hole and I'll take this pen like this in the middle, and around that we are having the paper, and if you start rotate that object, that paper will rotate around this fixed axis. So this turning effect or this rotating effect is nothing but what? Torque, or it is also called as a moment of force. Torque is also called as what? Moment of force. Okay, and this is the measurer of rotational effect, means how this object is rotating towards one fixed axis. That is also calculated with the help of what? Torque. Okay, so this torque is one physical quantity which will give us the rotating effect of the objects. Okay, so now what we have to do here now, we have to relate the angular momentum with the torque. So for that we should understand what is angular momentum. So as you know, in this chapter we are studying the objects which are under rotational motion. Okay, whenever the objects are in rotational motion, there will come with some different concepts, like when that object is changing its position, there we call it as a angular displacement. We call it as what? Angular displacement. Okay, and that is theta, I had told in the last class only. And when this displacement is changing, there will come with angular velocity, and when this velocity is changing, there will come with the concept of angular acceleration, right? Means when the objects are in rotational motion, the terms we study about that motion will differ, right? When that is in linear motion, there is speed, there is velocity, there is displacement, there is acceleration. All things you know it already in the mechanics. Okay, the same things we have to apply for the objects in rotational motion, right? So when you think of rotational motion, these all concepts will come. So there only we are getting angular momentum also. So what? Angular momentum. So what is angular momentum? Means the momentum of a particle. Means if this object is moving, its movement, how it is moving, right? The moment of momentum. Angular momentum is nothing but what? The momentum of a particle. Means when the objects are in linear motion, there we will get the concept of momentum na. P is equal to m into v, mass into velocity. So the moment of momentum here, because the objects are in rotational motion, here the objects are in linear motion, so this is momentum. P is equal to m into v. So this angular momentum is moment of momentum. Understood? Angular moment is nothing but what? Momentum of a particle about a fixed axis, about a axis of rotation. It is called as what? Angular momentum, and it is also the measurer of turning effect associated with the momentum. So momentum is nothing but what? The product of mass and velocity. So this object, it is moving, means it is also having one momentum. Okay, that momentum's movement is nothing but angular momentum. Understood? This angular momentum is defined as momentum of a particle about axis of rotation. Okay, and this is also measurer of the turning effect associated with the momentum of the particle. And you know the linear motion momentum is P is equal to m into v. So similarly, the angular momentum can be written as L is equal to r into p. Means, and all are vectors. Okay, the angular momentum of a moving particle is defined as L is equal to r cross p, where p is the linear momentum. P is what? Linear momentum of the particle, and r is the position vector with respect to the point. R is what? Position vector. As I told you, angular momentum is nothing but moment of momentum of a particle. R is the position vector and P is the linear momentum of the particle. Okay, now we can discuss the relation between torque and angular momentum. Means what is the relation between this tau and L? I told you in the last class only, tau is nothing but R cross F. Okay, what is this cross indicates? You know it already, vector product, right? So tau is equal to r cross F. F is the force acting on the particle and r is the again position vector. And from this explanation you know that L is equal to r cross P. So now we can discuss the relation between this tau and L. The relation between torque and angular momentum. How can we write the relation between torque and angular momentum? Okay, now the angular momentum of the particle having a linear momentum P is given by what? L is equal to r cross P. This is known to you. Angular moment is L is equal to r cross P. Let's call this as equation number 1. Now what we have to do, differentiate this equation number 1 with respect to time, t. Okay, now what happens? D means differentiate this equation with respect to t. So it is dl by dt, okay, and d by dt of r cross p. Differentiating with respect to time. Okay, now this is single term is there, dl by dt, keep it as it is. Here we are having vector product. Okay, now you have to apply here product rule. Differentiation you have studying maybe, so product rule, you have to differentiate this with respect to product rule. So what you will get? uh, keeping p as it is, differentiation of r, p as it is, differentiation of r, plus r as it is, differentiation of p, product rule. Okay, now this, see here what all the terms you got: differentiation of angular momentum, linear momentum, differentiation of position, and differentiation of what, linear momentum. Now this dr by dt is nothing but rate of change of displacement with respect to time, rate of change of position or displacement with respect to time. So this dr by dt is nothing but what, velocity, rate of change of displacement or rate of change of position. So here we substitute, in the place of dr by dt we can substitute v. Okay, so what you will get, dl by dt equal to p, dr by dt is nothing but what, v. Here we are having the negative signs, multiplicative signs. Okay, plus r into dp by dt. Okay, understanding? Now this p into v, this p is nothing but what, linear momentum, and its value you know it already, p is equal to m into v. Okay, now substitute here, what happens, p is equal to m into v into v plus r into dp by dt. Keep this as it is. Look at this term now. What you will get here, mv cross v. mv cross v means m is there but v cross v is there na. V cross v, in the last class only I told you, I cross I or j cross j or k cross k, all things will leading to 0. So here v cross v means it is what, 0. So you are remaining only with this term, right? So what can I write, dl by dt is equal to r cross dp by dt. Okay, now this dp by dt is what, rate of change of linear momentum. Dp by dt is what, rate of change of linear momentum, and the rate of change of linear momentum is nothing but a force. Okay, so what you got here, dl by dt is equal to r cross f. Now what is this r cross f? What is the r cross f? See here, r cross f is nothing but what, tau na. So right here, dl by dt is equal to tau, right? So the relation between torque and angular momentum is dl by dt. Okay, this is the relation between torque and angular momentum. Here you can observe one more thing, dp by dt is f, means f is equal to dp by dt, and tau is equal to, you got dl by dt. This is what, force for linear motion, this is momentum for linear motion, this is force for rotational motion, and this is angular momentum. Okay, now you can connect the things na. For linear motion this is force, this is momentum. For rotational motion this is force, this is linear momentum, angular momentum. Okay, so you can relate the things. So this expression will represent the relation between angular momentum of the particle and torque of the particle. So we can conclude that the rate of change of angular momentum of a particle is equal to torque acting on it. Okay, so this is what relation between torque and angular momentum. Now this was for a single particle, this all expression was for single particle. So now we have to connect with the system of particles. We have to connect with what, the system containing so many number of particles. So the means So for system of particles, what happens with the torque and angular momentum? Okay, now we can write that the system of particle means n number of particles are there. So the total angular momentum acting on all those n number of particles, can I write it as L? Means this is what total angular momentum on the system. Means I am not considering the first particle and its angular momentum, second particle and its angular momentum. No, the total angular momentum of the system of particles, that is L. So that L is equal to what? Vector sum of the angular momentum of individual particles. Means see, you are understanding or not? See, this is one system. Okay, in this we are having so many number of particles. In this we are having so many number of particles. N number of particles we are having. So on this whole system, the angular momentum is L. Okay, now this is first particle, this is second, this is third, you consider. So this first particle is having the angular momentum L1, second particle is having the angular momentum L2, third is L3. So the total angular momentum of the system of particles can be written as vector sum of angular momentums of individual particle up to Ln. So what can I write this? Summation Li, where I is equal to 1 to n. Okay, this is what total angular momentum on the system of particles. And as you know, when you are representing the summation, you will consider here ith particle. So what is this Li here? What is that Li? What is that Li we represented? See, this Li we represented na. What is this Li? Li is the Li is the angular momentum of ith particle. Li is what? Angular momentum of ith particle. So how can we write Li? Means what we got? L is equal to summation of Li, where I is from 1 to n. Okay, so what that Li we can write from the formula of angular momentum. What is the formula of angular momentum we had? L is equal to R cross P. So Li is equal to Ri cross Pi. So can I write this as summation I is 1 to n. Li is equal to Ri cross Pi. Okay, now again up means this is L. Again now differentiate. What we can get here? We have dl by dt equal to d Li by dt, summation of dli by dt. Means this dli by dt, li by dt is nothing, means dli by dt is nothing but what? dli is nothing but dli by dt is nothing but what? See here, dl by dt is nothing but torque we have. So here dl by dt summation of Li, means this is just I have given the value, don't worry about this. To this you apply the what? Differentiation. So dl by dt summation I is 1 to n dli by dt, and dli by dt is nothing but tau, you know it. Okay, so it is summation tau I. Okay, so here this tau I is what? Torque on the ith particle. This is what? Torque on the ith particle. Okay, but the value of torque also you know. The value of torque also you know, that is what? R cross F. Means what? This F is the vector sum of all the forces. This F is what? Vector sum of all the forces existing on that particle. But this tau is also having two parts, means the force is also having two parts, means the external force we are having, that is tau external, and the internal force we are having, that is tau internal. Okay, because but here we don't have any internal force, because the force between any two particles of the system is equal and opposite. You know it from the Newton's third law, right? And they are acting along the same line which is joining the particles. Hence this tau internal becomes 0, right? So we are only remaining with tau external. Okay, so see here what I am doing. Don't get confused. What I am doing, dl by dt, L is equal to summation I is equal to I from summation I is 1 to n and Li. Okay, to this I am applying the differentiation of Li divided by dt. dli by dt is nothing but tau I, but tau I is nothing but r cross f, means force. Okay, so on this system of particles, force is there, and that force is what? External force also, means externally on this object whatever the forces are acting, that is external force, and inside the objects whatever the force is there, that is internal force. But here they are saying that internal force is 0, because the force which the systems, these particles act on each other is 0, because whatever the force this particle acts on this, the same it will get back. Whatever the force this particle exert on this particle, the same it will get back. So all the forces get cancelled, so the whole system is having 0 internal force, hence it is only having external force, right? So what we are getting here, dl by dt is only equal to tau external. Okay, so this is what the time rate of change of total angular momentum of a system of particles is equal to sum of the, here we have sum also, na? Sum is also there. I is equal to 1 to n, means dl by dt is equal to summation I is equal to 1 to n tau external. This is the expression we got for the system of particles. So what can I conclude here? The rate of change of total angular momentum is equal to sum of the torques due to external forces acting on the system. Understood what I said? The rate of change of angular momentum of a system of particles is equal to sum of torques due to external forces acting on the system. Understood? This is what the angular momentum for system of particles. Okay, now conservation of angular momentum. The next part what we have, conservation of angular momentum, means if this tau external is the total external torque on the system of particles, what we have dl by dt is equal to tau external. So when this tau external becomes equal to 0, means if it means if on this system there is no any external force, means already internal force is 0, that is okay. But if there is no any external force also, at that time what this equation becomes, it becomes dl by dt is equal to 0, means differentiation of L is 0, means L is constant, na? Differentiation of any one parameter is 0, means that parameter is constant. This is from the differentiation, you know. So what conservation of angular momentum states that if the total external torque on the system of particles is 0, then the total angular momentum of the system remains constant. Understood? This only is known as what? Conservation of angular momentum. What is conservation of angular momentum? We have if the external forces acting on the system becomes 0, then the dl by dt also becomes 0. So if dl by dt is equal to 0, then L is constant. So what we can conclude here, that if the total external torque on the system of particles is 0, then the total angular momentum of the system remains constant. This only is called as the conservation of angular momentum. Understood? This is all about angular momentum. What all the things we studied? We studied what is angular momentum, how it is connected to torque, and what is relation between angular momentum and torque, and what is angular momentum for system of particles, and what is conservation of angular momentum. Okay, so in this part, if you have any doubts, you can ask me. So the next thing we come across with is, see here what all the topics we have. I have already listed. Next topic is equilibrium of a rigid body. Next topic is what? Equilibrium of a rigid body. Means what is rigid body? You know it already. Rigid body, I have explained this in the very first class only. Means the distance between every particle of that body remains constant. So the change in linear momentum of the rigid body, because rigid body, it can undergo linear motion also, or it can undergo rotational motion also. So when that rigid body, means if consider this is one rigid body kept at the floor. So when this rigid body undergoes linear motion, the force acting means the linear momentum is because of the force acting on that body. The change in linear momentum is because of force acting on that body. But if this rigid body is under rotational motion, then the change in angular momentum is due to the torque acting on that body. This concept is understood, because in linear motion we will get linear momentum and force. In rotational motion we have angular momentum and torque. So if this rigid body's linear momentum changes, that is because of the force. If this rigid body's angular momentum changes, that is because of the torque acting on that body. So when this rigid body's linear momentum and angular momentum are not changing with time, means what I am saying, if force act on this, its linear momentum changes. If torque act on it, its angular momentum changes. But at any condition, if linear momentum is also not changing and angular momentum is also not changing, so at that time we can call that this rigid body is in mechanical equilibrium. This rigid body is in mechanical equilibrium, means its linear momentum is also not changing, its angular momentum is also not changing. So at that stage, this rigid body is said to be in mechanical equilibrium. Understood? Equilibrium of a rigid body means what? The state or the condition of a rigid body when its linear momentum is also not changing with time and its angular momentum is also not changing with time. So the conditions for the mechanical equilibrium bodies are given. Means if you want to keep this rigid body at equilibrium stage, means if you want if this rigid body is what, linear momentum is also not changing, angular momentum is also not changing, means that is mechanical equilibrium. But it will not come to mechanical equilibrium easily. Okay, so if you want to keep this rigid body at mechanical equilibrium, you have to satisfy with the two conditions. Means conditions to make the rigid body at mechanical equilibrium. We are given with the two conditions over there. Okay, so what is the first condition? Means the vector sum of the forces acting on the rigid body should be 0, obviously, because if there is no force means no linear momentum, so it is at rest. No means, so the first condition is the total force on the body should be 0. I is equal to 1 to n. The total force on the body should be 0, because no force means no linear momentum. No linear momentum means no change in linear momentum, obviously mechanical equilibrium. Same, the vector sum of torque also. The vector sum of torque also should be equal to 0. So no torque, no angular momentum, the body is at equilibrium. Understood? This is what equilibrium of a rigid body means. This only this part you see. This is what equilibrium of a rigid body. Understood? What means this is, if this is one, you just observe this much thing. If this is one rigid body means, if it is rigid body, its linear momentum changes if force acts on it. Its angular momentum changes if torque acts on it. So when there is no change in linear momentum, when there is no change in angular momentum, at that stage this rigid body is called as, it is kept at mechanical equilibrium. Understood? This is the mechanical equilibrium state of a rigid body. So if you want to keep this rigid body at the mechanical equilibrium position, at that time you have to satisfy with the two conditions. First condition is what? Vector sum of the forces acting on the rigid body is 0. And second condition is vector sum of the torques acting on the rigid body is 0. Understood? These are the two conditions. If these two conditions are satisfied, then the rigid body is kept at mechanical equilibrium. Understood? So this is all about today's topic. Today we studied about angular momentum, relation between angular momentum and torque, and the angular momentum for system of particles, the conservation of angular momentum, and equilibrium of a rigid body. Okay, so this chapter is somewhat some means not much but very small queries will come in this, because it is not completely easy for you to understand. But don't worry, try maximum to understand this, and when you come to the college, at that time also I will explain it in detail. Okay, don't worry much about it. Whatever I am explaining now in the videos, you just go through it. Okay, so but if you got any doubts, you can ask me anytime. Okay, so till that, keep on studying. We can continue the class in the next class. Thank you.